So today we're going to talk about NoSQL injection. In the previous videos, as you know guys, we have talked a lot about SQL injection and we have covered a lot of scenarios. Today we're going to discuss something different, NoSQL injection. Before discussing NoSQL injection and before embarking on regular practical scenarios, let's first provide an introduction. So let's first compare NoSQL injection or NoSQL with SQL. What's the difference? Okay, so in SQL, as you know guys, the records are stored in tables, where the tables have rows and columns. As you know, you have like this. That's how it looks like from the inside. You have rows and columns. While on the other hand, in NoSQL, we have collections and we have documents. Now the thing is, the rows and columns here are equivalent to documents. And when documents are grouped together, they form what is called as collections. So in collections or collections in NoSQL correlates or corresponds to tables in SQL. And the rows and columns correspond to documents, if you will. Now, as for the format of data in NoSQL, that's an example of data stored in MySQL, in NoSQL, sorry. As you can see, the data is stored as key value pairs. You have the key, for example, here the key is ID, and then you have the value. The value here is the object ID, for example. The username, L. Phillips, and the email, for example, is with the value of the email. That's how the data is stored in a NoSQL database. So that's why we call NoSQL as non-relational databases. Non-relational, it means that the data cannot be related with each other using primary keys, as in the case of SQL tables. In SQL tables, the data is stored in columns and rows, where you can correlate the rows and columns using keys, or we call them primary keys. That's why we call it relational databases, rows and columns. But in NoSQL, the data is stored as sometimes in array format, as in the case here, and other times it may be stored in other formats. So in NoSQL databases, the data is not stored as rows and columns. It is stored as any other format, nothing or anything other than rows and columns. That's why it's called NoSQL. It's anything but not SQL. That's how the name of the that's how the name emerges. Okay, now let's talk about the operators. Understanding the operators is very necessary to master, or to get first at least introduced to NoSQL injection. First we have the equal. The equal, as the name suggests, when a field equals to a value. Nay or NE, it is when a field not equal to a value, GT, or a greater than, when the field is greater than a specific value. Where is the equivalent of where in SQL? It's for filtering. And exists, it is to make sure that the field exists, or to verify that the field we are using in the query exists. And this is self-explanatory that this is for regular expressions. An example query is here. Let's see. This is an example query. As you can see here, the username, we have a field username, and then we have equal operator, and the value is admin. And as you can see guys, in a NoSQL query we don't have and here. There is no and like in SQL. Then we have another field, password, and the operator used is equal and the value is admin. Now this query will look for the records in a NoSQL database where the username equals to admin and the password equals to admin. That's an example query. Okay, now we talked, or we provided introduction to NoSQL. Let's now cover NoSQL injection. So there are two types of NoSQL injection. First one is syntax-based. In syntax-based NoSQL injection, is very much similar to SQL, or the very basic form of SQL injection. If you remember, when you want to test for SQL injection, what you're going to do, you would provide, or you would inject a code or a single code to the username or to the field you are manipulating. For example, here, let's say we have a username as the username is admin. Okay, so when you want to test for SQL injection, we would here a single code. Same with NoSQL injection. The syntax based, it works based on injecting a single code to the field. Now, the thing is, with syntax based, it's not that popular because most of the modern web applications and databases, they use filters that prevent this type of injection from manifesting or from manifestation. That's why we actually resort to the other type of NoSQL injection, which is operators based. In operators based NoSQL injection, what we do, we manipulate the logic of the query. We use the operators given here to manipulate the logic of the queries. The other operators, such as the NIN, that's very much used to return records where the field not equal to a value. This is very much similar to not equal. We use this in NoSQL injection a lot. So why do you use operators based? Typically, as with any form of injection, we aim to bypass login forms and to extract records. Now, for the practical scenario, or for the demonstration of the practical scenario of this video, we are going to use the room in TryHackMe named NoSQL Injection. The credits go to the authors of this room for creating the practical scenario. And here we are given a couple of tasks to answer. Now, as for task 4, 5, 6, we're going to provide the answers. As for task 7, it is on syntax injection. And since syntax injection is very much rare, I'm going to leave the task 7 for you guys. You can do it on your own. If you are stuck on getting the answers, you can take a look at the answers in the write-up of this video that I'm going to put in the description. These are the answers here, but anyway, you can take a look at them in the write-up. Okay, so now let's start answering the questions, and while answering the questions, you will see how NoSQL injection works. So here we have Purpose Suite up and running. We're gonna turn the intercept on, and in the browser we have this web application that has a login form. Before doing anything, we're going to turn on the Foxy proxy and switch perp on. Start with a username and password for testing purposes, test and test. Send the login, and here we can see the request. It is a post request, and as you can see, guys, these are the fields: user and pass, and we have the remember. As for the remember field, we're not gonna need to give it much attention here. We only need to tackle down the user and the pass. It's very much important to be familiar with the fields used in the request before starting any injection, right? So we have the user and we have the pass. Okay, let's start with a basic injection. The basic injection aims to extract all the users stored in the database. So for that to work, we're gonna have to rely on operator NoSQL injection. So the operator we can use here, it comes after the field, and we use two brackets. Okay, inside the brackets we're going to inject the operator. Now in our case here, we're going to use the not equal operator, so NE, and as with the password, we're going to use the same operator. Okay, now we know what is the operator, or we injected the operator. Now what this does basically, so we have the user not equal to test, and password not equal to test, and remember equal on. This is a basic trick that will let the database search in its records for all usernames and passwords where the user not equal to test and password not equal to test, and as a result, if the values here do not exist in the database, the database will return the records of all the users and passwords where they don't match the given values. That's a trick in returning or extracting the records. The only thing we have to pay attention to here is to make sure that the values we provide for the user and the password do not exist in the database. You can try rubbish values or values that you believe they don't exist. Test and test, we know they don't exist. That's why we're going to use them as values to the user and password fields. So we're going to send this to the repeater, and here we're going to send. Take a look at the response. So here we got 3 or 2 response, and looks like the response is valid. Look at this, the location. It has actually returned a page named like secret place coded with numbers. Anyway, so let's try this out. Gonna click on forward. Okay, now we take a look at the browser. We see here, guys, the page returned the admin user, because the admin user, the user not equal to test, and the password doesn't equal to test. That's why it has been returned. Now you can see the data of other users. Now this will answer the task for the questions. Let's see here. When bypassing the login screen using the any operator not equal, what is the email of the user that you are logged in as? It is admin. As you can see, we are logged in. It is true that we don't know the password, but we are logged in. So we bypassed the login screen using this method. Okay, now let's log out and take a look at another trick. So if we resend the same request, and this time, or let's go to Purpose Suite, we have the repeater. Okay, so what's another trick we can use here to return the records, extract the records? In the first example, we were able to log in as the user admin because it is the first user in the database whose values don't equal to test. Remember that this method only works, or it works in returning the first user whose username doesn't equal to test or whose password doesn't equal to test. Okay, it returns only the first user, which satisfies the condition here. What about if I want to return or to log in as other users, or if I want to extract records not only for the first user but for other users? If that's the case, I'm gonna have to revise my methods. So here, instead of this operator, I'm going to use the other operator. This operator will work similar to the not equal, but it will return all the records, not only the first record that satisfies the condition. So here I can use this method, for example, and I can test it. So here I can use also nin send test to request. So it is internal server error. Okay, we have a problem here. I think we're gonna have to put a pair of empty brackets here, and this one, it has to stay as the old operator not equal. Okay, so the response is valid. So what happened here? Here we told the database to return all the users, not only the first one. Remember this, all the users where the user field doesn't equal to test and the password does not equal to test. It works similar to the previous one, but the thing is, remember that it returns all the records, not only the first one. If we have this over to the request, let's copy this and go turn on the intercept, go back to the browser and send another request. Let's try one more time. Okay, if we send this now, let's see what the response looks like. So turn the intercept back off, go back. This time again we got the admin user. Okay, now assume that I don't want to return the records of the admin user. I want to take a look at another user. It might be the case that there is only one user in the database, which is the admin, but you have to verify your hypothesis by testing for different scenarios. Also, we're gonna have to log out one more time, inject other tests, and then turn back to intercept. Okay, send. Okay, we can have the same payload copied from here. This time I'm going to use and here. Okay, and I'm going to use the same field. We can use the same field in more than one condition. So user, again, name not equal to, and here I'm going to put admin as the value. So this will return all the records, okay, where the user does not equal to test and admin all together. If we send this, now we have another user, Pedro, and that's the email. Before we continue with the rest of the scenario, let's have a look at the answers. So here, how many users? Okay, how many users are there in total? And there is a user that starts with the letter P. What is his username? So we already answered this question. As you can see, the user is Pedro, and this is the email of the user. Okay, now to answer this question, we're gonna have to keep on testing. So we're gonna log out this time, go back here, send another request, intercept is on. Again, we're gonna have to copy this from here. Okay. Looks like we have a problem in copying. I hate this, by the way. Okay, so here I'm gonna exclude the admin user, and I'm going to use the same payload user with the same condition, with the same operator, equal to Pedro, and send it. Now it's supposed to log me in with a user that doesn't equal to admin or Pedro. Let's have a copy here. I'm gonna put it somewhere here just for testing, and we're going to send. Now we have John. So in total now we have 3 users. So this, I'm gonna revise the query, and this time I'm going to add another exclusion for the newly discovered user. So user equal to John. Yes. I'm gonna have a copy here. Delete this from here because I don't need it, and then I'm gonna go back to the browser, make sure this is okay. Intercept is off, log out, send. Okay. So here, the user that will be returned will not equal to admin, Pedro, or John. So in total, now we have 3 discovered users. They are valid users. I'm gonna forward and see what is the response of the server. So we have here another user named Secret. In total, you have now 4 users, which matches the answer for this question. Now you can keep on testing, but for this scenario, it's gonna be useless. So this is the user and this is the email. We don't know the password, but we can change in a practical scenario. When you are logged in as a user, you can simply control the user fully by changing the password, right? As for password reuse, if you want to use this password in other, if you believe that the user secret, for example, has the same password used in other services, then I'm gonna tell you, you have to you have to determine what is the password here. In this case, it's going to be compulsory. Now log out and move on to the next scenario. We're going to work on guessing the passwords. Okay, in the next scenario, we're gonna have to work on a method to guess the passwords. Remember that we have discovered 4 users. Among the users are Pedro, admin, and John. What if I want to determine their password? As I demonstrated earlier, if I suspect that these passwords are used somewhere else, like in SSH or over FTP, I'm gonna have to guess the passwords, because if I guess the password, I might be able to log in to other services, not only the web admin interface, but I might be able to log in to the SSH or to FTP or any other service. That's why I have to work on a method to guess the passwords for the users, which I have compromised. So for that to happen, we're gonna have to rely on regular expressions. So in NoSQL, we have this operator that can be used for regular expression queries. Let's take a look at it. So here we have a request already in the repeater. We're gonna work on this view. So remember, guys, that there was a user named admin. Say I want to guess the password of the user admin. I'm going to cancel the operator here, and test will be replaced by admin. And here I'm going to use the operator regular expression. Where I'm going to apply this operator, I'm going to apply it on the password field, because I want to guess the password. So here it goes. And then I'm going to specify the matching conditions. Okay. The first thing to work on is to guess the length of the password. If I guess the length of the password, I will have first clue on how the password looks like, the length of the password, and then I can work on guessing the alphabetical composition of the password. So here, let's say it's gonna be just a wild guess, and based on the response of the server, we can verify the validity of our guess. So you're going to assume that the password is composed of maybe 6 characters, and then we can send. Okay, so here, as you can see, we got a valid response indicating that the password might have 6 characters in length. If we try 7, inside curly braces, I put in the expected length. So as I said earlier, it's just a wild guess. Let's suppose that the length is maybe 9, and then I end it with a $sign, and I send the request. So here we have the response from the server. If you take a look at the location, you can see it is erroring out. There is an error, which means that there is something wrong in this query. Now, we know that the username admin is valid, which makes me conclude that the problem is here. It means that there is either a problem in the expression or in the length of the password. Most probably it's the length of the password, which is. So if I change the 9 maybe to 5, still we have an error. It means that the password length is not 5. Try with 4, still there's an error. If you try with 8, which might be the correct value, and now we get a valid response. There's an assigned cookie, and there is the return page. So that's the length of the password of the user admin. And the next step, we want to guess the password. I know it is hard and it requires a lot of trial and error. In a regular scenario, you might want to use the intruder. In the intruder, you might want to specify a payload. Iterate through the payload and brute force the password. But for the sake of this scenario, we're going to use the wild guess. So now we know that the password is 8 characters. We're gonna change the expression now. We're going to assume that the password starts with a letter B, right? And then for the rest of the characters, I represent them with dots. So I have the password length 8. I used B, so now the rest is 7 characters. I put 7 dots. 1, 2, 3, 4, 5, 6, 7. And I send. Let's see the response. Now we get an error because the password doesn't start with B. You can keep on doing this until you reach the end of the alphabet, which is the letter Z. When you get a valid response, it means that the password starts with A. That's the easiest method to do it. You can still start at any position here, the 5th position, the 6th position, or the end of it, to guess the valid characters that compose the final password. Now, as for the scenario in this room, we are required to guess the password of the user John. Now, in the hint, it's telling you that the password consists of only numbers. Okay. First, we're gonna have to guess the length of the password. Now, let's first change the user to John. And here, change the expression back to the old one, with curly braces and the expected length. Let's first save time and start with 5 because it is the right length, I guess. No. Let's try with 8. So 8 characters is the right length for John's password. Let's now start working on guessing the characters. Okay, so now we know that it's 8 characters. Let's start 8 characters, and we know from the hint that the password is composed of only numbers. We're gonna start with 1. We're gonna assume that the password starts with 1, and for the rest of the characters, I'm gonna use 7 dots. 2, 3, 4, 5, 6, 7. An error. Let's see the okay, we have to cancel the dot before the 1 sent. And there is a valid response. This means that the password indeed starts with 1. Okay, now on to the next dot that represents the second character. We can start with maybe 1. Okay, now it errors. It means that the second character is not 1. You can go back to 0, and now it works. Now we guessed the first 2 characters of the password. As for the third position, you can try 4, not 4, 5, and 5, it works. You keep on doing this until you finish all of the characters, and you will find that the password is this. Okay, one of the users seems to be reusing his password for many services. Find which one and connect through SSH to retrieve the final flag. That's what I mentioned earlier. You might have to guess the password in order to use the password to log into other services. Take a look at the hint to save your time. The user is the same as the answer for question 2 of task 5. So task 5, question 2, Pedro. So we're gonna have to guess the password of the user Pedro here. Okay, we guessed the password of the user Pedro. We use the same password to connect to the SSH server as Pedro and retrieve the final flag. Okay, so here we modify the user to Pedro. Okay, and we go back to the same thing. First, we're gonna have to guess the length of the password. Now, the length of the password, as I remember from doing the room the first time, it is around maybe 8. Let's try. Not 8. Maybe I guess 9. Yes, 9. Not 9. 10. Still not 10. What about 11? So 11 is the correct length for the password based on the response. Okay, so guessing 11 characters may take some time, so I'm going to give you the password, guys. It is cool pass 123. That's the password. But how we guessed it, you can just again do the same thing that we did earlier. Start with the first letter of the alphabetics, and then continue on with the rest of the dots, which happens to be 10 dots because the password is 11 characters. So C, assuming the password is correct, cool pass 123. We start with C, and then we use maybe cool. Okay, so now we used up to 4 positions. 11 minus 4, that leaves us with 7. So we have 7 dots. 1, 2, 3, 4, 5, 6, 7. Send. There is an error. Yeah, we have to remove the dot before the C. Send again, and it is valid, which means that the password starts with the word cool. Okay, now we go on. Cool pass. Okay, let's remove the dots here and use pass. So now we used up to 8 positions, and 8 minus 11 equals to 3. So we are left with 3 dots. 1, 2, 3. Send, and it is still a bad response. Okay. Now you might be telling me, how do you know that the other characters are numbers? Basically, when you test for the alphabets or the letters and you won't find a match, or the response given by the server is still not valid, which means it might our strategy might need to change from using letters to using numbers. So here 1 and valid. Try with 0, you will get an error because the password doesn't contain 0. So knowing that the password is cool pass 123, let's now connect to the SSH server. Okay, this is the pass. And we're in. We have the flag, and this is the final flag. As for task 7, in task 7, as I told you guys, these are the answers. It is on syntax injection. As syntax injection is not that popular, we're not gonna cover this task, but these are the answers anyway. So guys, that was it.